that other one that you're aware. But still, it's live. Some part is recorded, and Q&A will be live. So this is an overview of digital design solutions from basically design to rail, with a focus on rail projects. And with me here today, I have Mylin and Xing. So Mylin is a specialist in the software, the open rail software specifically, and Xing is our Plexus geotechnology experts. That they will be speaking later, because one reason to do this webinar is ongoing metro projects, and a lot of them involve tunnels. So that's why the geotech, so we focus a bit on that. On myself, I'm with Bentley for even more than 3 years now, I think. Before that, I worked in the industry, coming from initially an architectural background, and then worked in transportation projects, but more like airports and stations. From there, then I worked with contractors as well, and got into also the linear. When I later joined McDonald, I got into the linear aspects of tunnels and linear alignment. And but I'm like a generalist digital consultant across applications, so I cover anything from buildings to rail and roads and the interfaces, and that's sort of my role, to see how things fit together for large infrastructure projects. So that sort of connects to a few words about Bentley, that we have around 200 odd applications, and therefore, so our biggest focus, at least in Southeast Asia, is large infrastructure projects that have several components, which might include rail, road, whatever is around buildings as well, usually, and scanning the topography and what is underground as well. So that's the primary focus of our company. So we have a different software that covers anything you might imagine, actually, in the realm of infrastructure. And just to highlight, that's why we're also focusing on how to integrate and work together between different offices and different sub-applications of Bentley. These would be on the DGN format, and the common data environment. Some of you might know ProjectWise. We also call it connected data environment, because the idea is to, in a cloud-based environment, reference together these different aspects or elements of a project. That could be like a rail. It would be, for example, a station and the rail alignment, viaduct, or tunnels, or all connected, or substations, things like that coming in. And as I said, so the DGN format, that's coming from MicroStation. That many people are more familiar with the MicroStation terminology than Bentley. Bentley is nothing to do with a car, by the way. So we're a software house, and the MicroStation DGN is that something where Bentley grew up from the 80s with, and then open roads, open rail, open buildings, these and many more, like you see the circle here, they're all based on the DGN format, so they can be referenced together. Even the geometry definitions are slightly different for buildings, for example, where we have this buildings BIM requirement that's more detailed, whilst in the open rail, you go larger scale, so you need to have ability to span more, so that the geometry is more faceted, more coarse, but they can be referenced together. And we also have workflows where we can start with something more course and then go more defined and end up with a BIM level. So here's an example how the station and the tunnel is referenced together. We call this a federated approach, which is pretty much our sort of approach to BIM and anything beyond. And coming back to to the integrated workflows in the common data environment. Just to highlight here again, this would then enable the contractor, subcontractor, fabricator, owner to view these different models, and not just the models, all documentation, whether that be like from Bentley source, or it could come for PDF, or anything that's part of the design project workflow is meant to be in a common or connected data environment, and then the access is managed, meaning we define who is the author, who's the reviewer, who's giving like the go ahead, this is good to go into for design, to share with others, into construction, and so on. That just on the side, that's not the main focus. The main focus today, I want to sort of highlight our like BIM for linear infrastructure, basically. And there's a bit of a debate going on. Like, I wouldn't say that you can just say these civil engineering software tools, which like the Bentley version is Open Rail, Open Roads, whether that's BIM or not, there can be a debate about it. I still say it's following similar principles, because what we have is we have the geometry and we have associated data with the geometry. Even these data schema are not necessarily IFC, and there's also debate, because IFC for infrastructure came out, but is not fully settled, is not something that's fully adopted by the industry. And there might also be a debate whether it should be, because IFC is coming from buildings, like BIM buildings background. Now, in terms of geometry, what are the fundamental differences here? A BIM for buildings, like Open Building Designer, would be our software for that. Others use Revit, for example. These are based on a grid, and everything sort of stacks up on the grid. So, and when something shifts, the grid shifts, or the wall shifts in relation to the grid. Even there's a curved wall, it's grid-based. The chainage-based, or you could call it alignment-based approach is different, where when you have that approach, you're following an alignment, and these could, of course, be several alignments that submerge, or there could be forks and so on. They go up and down, and there's radius, there are straight parts, and a clotoid as a transition, for example, as on the right-hand side. So this means that any change in alignment would then have an impact on all different things that follow that alignment, like the road itself, embankment, the street lights, for example, or any other things like that. And this is the fundamental thing where I've seen BIM teams struggle when they move from a buildings approach to a linear approach. So that's one of the key messages from my perspective. I also moved from a buildings-based background to linear design. And yeah, so one is grid-based, the other one is alignment-based, and things happen at stations. So at station, at kilometers so you have a bridge, and then you have embankment, then it goes up, down, and so on. It's a bit like driving along a motorway. Yeah, and you imagine like sometimes you have these sort of indicators on the side that tell you where you are. And on the other hand, the building is grid-based. So yeah, that I think even it's a bit repetitive. I still think it's important to highlight that very fundamental difference in terms of the geometric definitions. Now I want to quickly show a project to highlight what is the benefits, what are designers and ultimately also the whole supply chain behind, and contractors and owners, what is the benefit of that type of 3D civil engineering tool, or BIM for infrastructure, however you call it, approach. And I came across a project that's, it's already like 2 years or so old, but I still think it's a very good one to highlight, because on that project, there really, it shows all the different things that happen in and around a linear project, which is not just the alignment, as you see here, because it's the surrounding buildings, is parks and other infrastructure, the stations. And in this Bergen is a city in Norway that has if you've been there, it has mountains and the ocean, and so it's quite complex in terms of, basically it covers all the elements that any typical MRT or rail project would have. I'm not going to go through all these facts about, but you see it's a substantial project. So, yeah, coming back to design principles. So here you see the tram track that's basically following the alignment. And then the question is, what happens with these more detailed elements that are designed alongside? So things like shelters or stations, bridges, some of this would be like a building typology. And this is where this team then referenced together the civils models with the buildings models to like that. That is part of the federated approach. And then one key thing here is to mention, I want to highlight, is the computational design approach, whereby you have an alignment and you have a lot of detailed requirement that in this case was actually a BIM LOD 300 or even higher requirement. And you have an alignment that's changing. So often alignment might change and the detail is already established. Now, in this situation, we use an approach which is called computational design. And as you see here, the tracks are following the alignment, and what is below is a script, is a visual scripting, meaning these boxes that look like wired together modules. That's what they are. And each of these contains script that define a geometry and where it's positioned. So this means we can have a computational scripting approach without all of the members of the team being able to script. And the alignment engineer might make amendment to the alignment. That is the civil engineering software, which can then be referenced into, in that case, it was EcoSim, which is now Open Building Designer. And we can then follow with the script, we follow that same alignment. And by doing that, and here comes the advantage, you actually save a lot of man hours when the alignment changed. You just rerun the script. And this is a key benefit for the designer. Of course, the designer saves time, but also the contractors or owners involved, they would see a quick feedback of what happens, because you can then schedule out, like the amount of sleepers you might have, or the length of track, or all these can, because it's in a BIM format, we can get a feedback on what this alignment actually did to cost as well. Yeah. So here these are the figures, how many things were moved by the script. That's on that. And then I wanted to highlight another thing. So which is to do with the digital twin. So the digital twin approach, actually it at the basic level, it follows on from, we had the tool called Navigator that's similar to Navisworks from competitor you might be aware of. And that tool is for design coordination and coordination between also not just one software, but you could have different consultants collaborating. They would bring in typically different formats. The iTwin, which is our take on the digital twin, that is basically taking it all in, and it looks a bit like that type of coordination software that, like Navigator, you're used to, but it has additional functionality now, and we keep adding. So at this level, you could, clash detection is there, but then we have additional functionality, for example, to highlight in color what's added, what's new, what's removed, for example, and you can get that output. And when a geometry changed, you can also compare between one version and the next version. And you see geometry changes and you can compare them, list them out and go through them. And then, of course, this would follow a design coordination process to accept, reject, whatever changes happen. So on a design coordination basis, this is probably not too unfamiliar to BIM coordinators, BIM managers, but it's extending the clash detection. Here we see one version to another, something detail has been added. And these things, of course, are very relevant for contractors who, you're thinking about claims of changes and so on, to have a control of what changed from one version to the next, have that automated and visible is somehow a key thing for between design and construction. So, a few more things about the digital twin concept. I had debates, is digital twin replacing BIM or CAD, or is it CAD then BIM then digital twin? I see it more like, well, these should actually, BIM and CAD should be inside the blue ball, actually, because the digital twin idea is that I bring in everything, 2D CAD models that have IFC structure behind it, models that maybe have no data associated, or a rail definition or plant definition, right? Like, so you could have large infrastructure projects where many different things come together. And the idea of the digital twin here is then structure that and not say only IFC data can enter, but any data can enter, we just need to manage it. And the idea is also to be open, which is why this JS is a JavaScript-based format, is open to build connectors. And we've already built some in-house to not just between the different Bentley tools, but also connecting to competitors. And every week I'm talking to people who like to extend that to more formats. What you see here on the screen is the ones we've sort of dealt with to date, but it's evolving, right? Like, this is something, it's maybe the latest hype, you could call this digital twin idea. And for me, it's just to bring together or to link or to connect to anything that you think is relevant to connect to for your project. This is the concept house works. On the left-hand side, you have your authoring models. There could be many more, but here's 4 that might ring a bell. We then go through a process and bring that into the iModel hub, which is like our federated container where everything is linked together. But if you would see it all at the same time, you'd be overwhelmed, right? Because it'd be too much, you wouldn't see the wood from the tree. Therefore, then on the right-hand side is a list of applications that could be handheld devices for site or HoloLens, overlaying models with what we see in reality. You could have Power BI based high-level view for like management to do cost control, or dedicated to that. Several. Now, this is just to give an overview. And just to say what's coming, what we're working on is really to integrate also things like sensor stream data like SCADA into this, where the mining and plant industry, or region where we bring human behavior in, that is now not yet linked to the iTwin data, but instruction sequencing is another thing. The iTwin digital twin fully, we have the reality modeling, the scan reality overlay as well. More on geotech. That should also be all part of into the technical applications. So over to you, Mylene.
Okay.
See how this position.
Okay. So I suppose everyone can see my slide. Okay, so I will proceed. Good afternoon, everyone. Again, I'm Mylene from the Civil Engineering Design Integration team of Bentley Systems Southeast Asia. So today, as Dominic has mentioned, I will be focusing more on the civil design solutions of Bentley, specific for linear projects, and of course, with emphasis on rail solutions. So let's start. Okay. So in this slide that you're seeing, this is how most likely civil design integrates or collaborates with other disciplines in a typical project. Okay, and then for each of these boxes, that basically shows a workflow. Okay, it has a specific Bentley solution from where each of the workflow have a discipline-specific solution. So starting from survey to the civil concept as well as detailed design, to the architecture, MEP, and structural modeling of buildings. Then, of course, there would be need for reporting as well as analysis of probably building as well as geotechnical data, up to the point wherein you do visualization and then, of course, construction simulation. And then as Dominic has mentioned about the digital twin, okay, so we also do digital design review. So for each of this step in the workflow, Bentley has a sure solution. And of course, working at the background is the connected data environment facilitated by ProjectWise that makes every step of the workflow effective and well integrated. Now, in my presentation, I would be focusing more, as I've mentioned, on the rail civil design aspect of the workflow. Okay. Now, we have actually two major rail solutions, both for conceptual as well as detailed design. Although due to time constraint, we only have like around an hour, okay, to discuss. So I'll be focusing more on the detailed design, which is actually Open Rail Designer. And just to be clear on what you actually get when you have Open Rail Designer. So Open Rail actually also contains all the functionalities of our other powerful road and site design solutions, namely Open Roads Designer as well as Open Site Designer. So hence, in a single solution or software, you also get to do not just rail projects, you can also do road as well as site projects. And to simplify it, okay, I hope this simple Venn diagram actually depicts, okay, more or less the overall civil design solutions of Bentley in terms of the functionalities it has in delivering projects for rail, okay, for roads as well as site. So in a nutshell, if you have open rail, you have functionalities of open roads. If you have open roads, you have functionalities of open site. Okay, so basically everything in open rail. Okay. But to be specific, in terms of the rail detailed design, of course, apart from you doing terrain modeling as well as survey, okay, creation from your conventional survey data, okay, you can also, of course, create alignments that has turnouts, and of course, do regression of your horizontal as well as your vertical geometries or alignments. Then, to be specific on rail design, okay, you can apply speed tables specific to rail, and then of course super elevation, or some would refer to as CANT, okay, based on specific design standards that you would input in the workspace of Open Rail Designer. Then if you would like to maybe focus on the modeling part, okay, you can add in rail and sleepers, and then do or create a swept or sweep envelope that runs along your alignment, okay, so that you more or less can see how the car is especially if your space is limited in a tunnel type of a corridor, so how it depicts the cross section, okay, of the car or train car along your corridor. And of course, if you're aiming only for LOD 200 of putting in your overhead line and electrification furnitures, we also have that in Open Rail Designer. Okay. Now, what makes Open Rail special among other civil design specific applications in the market is that we basically open roads as well as open site designer. We have this called template-based approach of creating and applying, or creating your corridor and applying your design standards. Okay, and it addresses, okay, basically all the complicated and real world, okay, scenario you would like to depict, okay, in your corridor model. And this is basically, okay, would be very, very useful when you want to create a dynamic 3D information model of your corridor. Now, in a gist, I think the template cross-section, okay, the backbone, okay, but then of course the terrain model as a reference to indicate that your project is really underground. So once a dynamic 3D corridor model is generated, the next step in the workflow is to have it populated with all the utilities or MEPs along the tunnel, or maybe if it's a crate, all those rail furnitures such as overhead lines, okay, including the utilities underground to very much complete the modeling workflow. Now, let's dive deeper on the benefits of using this template-based approach that I have mentioned for your design and modeling, okay, of your rail information model. So as you saw in the previous slide, and also in the image below that I have here on my slide, templates are like your typical cross-section, which actually facilitates the creation of the pavements and pavement materials and quantities of your corridor. It also generates the 3D linear elements, which will become useful later on in your succeeding workflow, as I will actually, Dominic has showed a bit of it already, but I will hopefully expound on that in the last part of my presentation. So these linear elements came from the points that were parametrically constrained during the template creation. And if your rail corridor happens to be at grade, you can also dynamically rule them to allow cut and fill of the existing terrain. And we call that end condition. Okay. Now, here are some examples of the templates or cross-sections that are available in OpenRail. But of course, you are not limited with these types. Once you really understand the basic principles of creating templates and how to constrain them, okay, or apply rules on them, you would literally create many design scenarios, okay? And you will see that OpenRail offers a real-world approach in terms of design and modeling of your corridors. Okay, so here is an example of an at-grade template of a single track, which has previously been assigned with point names. And each of these points actually tell a story on how they behave once used in your corridor. Probably starting with the center line, which actually follows your horizontal and vertical alignment. Okay, you put in points either on the, or since this is rail, you put in points on the left or right side. Okay, that basically represents the top of rail, inner or outermost edge of the rail itself, and then from there you can simulate the behavior of the super elevation, and you can already test it out in the interface so that you would know more or less how the cant or super elevation would behave. Similarly, if you would do end conditions or cut and fill of the ground. And same scenario can also be applied if, let's say, for instance, you have a two-track, okay, or maybe a tunnel, or maybe a bridge deck. So there's quite a lot of examples that are available already once you install the software. But as I've mentioned, you can create as many scenarios as you can, okay, depending on your project. And then this is just a simple video showing you how cant, okay, calculation is applied, looking at the cross-section of the corridor. Okay. The sample is an at-grade rail corridor. And as you scroll for specific chainage or station interval, you can see that the top of the rail super elevates. And it would be the same behavior regardless of what type of corridor you are creating, as long as you load in or you set the constraint in your templates already and then have them follow a cant calculation, and then the software will do the magic for you. Okay. Now, as I've said, okay, the template actually creates points, okay, that also creates or generate linear elements. These linear elements can then be used as reference lines of your or reference lines of other open applications of Bentley. So one example has been shown already by Dominic using EcoSim or Open Buildings Designer, okay, so that you can complete or continue on with the design workflow. Okay, and then this video I'm showing is actually similar to what, in a way, Dominic has shown. Okay, and this actually would basically finalize as well my presentation. The dynamic corridor was created using OpenRail, okay, with all the constraints, linear elements, or critical linear elements created, including the alignment. Okay, and it is being referenced inside Open Buildings Designer. And by using computational design tool, which are already built inside OpenRail as well, and of course Open Buildings designers ever since okay. So if the alignment is updated as you show in the video, corridor will dynamically adapt to such inevitable changes that happens. Okay. However, having a common data makes the workflow seamless. And as you see here, all you need to do is just update the script, and then this used to be quite a headache. I think many would relate that this used to be like a big or huge headache for those who are doing a similar project like this. So every time the alignment changes, you need to really go back and remodel what you have started in the corridor, or probably all those utilities that you have laid out, especially if your level of detail are quite high. Okay, so with this workflow, okay, it would be, I mean, most of the time, some of our users would only update the script and then see the result in minutes, not the typical headache of waiting for days in order to view what is happening in the design, or just to depict whatever you want to see in your design. Now, going back to the workflow, okay, since I'm finishing my presentation. Okay. The same is true if in case, because I think some of you probably, okay, at this stage here, would probably be using another software. It would be ideal if you are going to use, of course, all Bentley solutions. But as Dominica said, okay, a typical scenario would be you'd probably be using other softwares. Okay, so this workflow would stay the same. Okay, even though you'd probably be using another solution for this step of the workflow here, and it would still work basically because maybe you'd be outputting the model you created in OpenRail to an IFC, or even just reference the DGN or convert it into other format. Okay, so depending on the level of detail that you would require, okay, this part of the workflow here would basically would basically be a good interaction, or there will be a good interaction between this step of the digital design workflow. Okay, and this concludes my part of the presentation today. So I do hope that you were able to understand how OpenRail Designer fits in the overall workflow of delivering linear infrastructure project. I did not go really onto the technical details of creating the corridor itself because we have other dedicated webinars for that, okay, for OpenRail, for OpenRoads, and even OpenSite. So that's why I just went on to the overall picture as to how you can use, or how you would place OpenRail Designer in such kinds of projects. Okay, thank you, and I'll turn you over to Singh.
All right. Thank you. Good morning, good afternoon, which might be the case. I'm Singh Chen. So following the presentation from my colleagues, I'm about to take you through an overview of tunneling solution from a Placis perspective. The market for tunnel construction is growing fast to meet the ever-increasing demand for underground space. And tunnel serves the multi-purpose of transportation, utilities, and storage, etc. Provides the major means of access and connection to various underground structures, as well as the intercity link across canal and mountainous landscape. Just a quick overview of tunneling methods. In general, it boils down to the mainstream of mechanized and sequential excavation method, fit for different purpose and scenario, and quite often used in combination in a typical tunnel project. Construction activities like underground tunneling disrupt the equilibrium of the subsoil and inevitably cause disturbance to the ground surface and the existing infrastructures, despite the tight control we implemented during the construction. In most of the cases, we managed to downplay the negative impact of such to minimum with sound and proven guidelines, but nevertheless, unexpected happened and warrant some of our attention. There is a call for us to address the geotechnical concern arising from such construction activities. As computational power nowadays is cheap and attainable, there are growing interest in using computerized programs to analyze complex geotechnical problems. And that's when Placis comes to fit in, as a well-established FEM package is able to account for a complex soil structure interaction, so it's a wide range of behaviors that concern practitioners. Let's you, for instance, simulate closely the construction sequences and compute the deformation and structural response as a result. The module structure further expands its capabilities in capturing the sophisticated coupling of thermal, hydro, and mechanical behaviors. Here you can, for instance, simulate the ground settlement due to loss of groundwater during tunneling activities, as well as how the phenomenon takes place over time. Alongside more application unlock, for instance, for tunneling in poor ground conditions, with the principle being to start the groundwater seepage and thus improve the stability overall. And here, you may as well take to a full-scale three-dimensional analysis and simulate the tunnel advancement, also the variation of ground condition beyond just what's going on in the 2D plan. You can model at ease the sequential excavation method, EPB shield tunnel construction, as well as the TBM advancement. Through the analysis, you get to evaluate the phase stability and optimize the support pressure. And after the analysis, you can, for instance, query the settlement trough along the tunnel alignment. Tunneling involves numerous cycles of repetitive construction activities. Number of cycles depends on how big a slice we want to cover in a typical stage. And if the ground condition permits, we would certainly want to do more. Tunnel designer, as the center of the entire modeling workflow, really had undergone major improvements over the years. Allows you to predefine those recurring construction activities taking place in a typical tunnel advancement cycle. And that way you no longer have to manually define those construction activities for each phase, but just one click away to have the right settings in place. You can, for instance, dictate when the tunnel advancement is going to pause or resume. This is relevant for the case of TBM. You just have to stop at some point for cutter head inspection or replacement. And of course, you are considering also the time-dependent behaviors. I mean, the logical workflow makes adapting to construction schedule a nice experience like never before. So imagine how this is going to help you out tremendously if you had to deal with hundreds of slices of such, over the course of a few kilometers, to say the least. And now, as real as it gets, you can consider erratic subsoil profile in the analysis, as well as the tunnel alignment. Alignment of tunnel is affected by a number of factors based on the end use of tunnel and existing land use. For many urban tunnels, this factor controls both the vertical and horizontal alignment. On the contrary, there is often limited scope to alter the alignment in better ground though. And storage caverns are, however, a major exception, as economy of construction is often the governing factors. Mechanized tunnel construction, or TBM method, just to sound a bit commonplace, the method involves a customized tunnel shield, mostly circular if not rectangular, adapting to the desired dimension of the tunnel to be constructed. It is equipped with cutter head gripper in the bore front, depending on the ground condition, as well as the excavation, slurry, regulating chambers depending on the type of the chute. The idea is to maintain a sufficient phase pressure during advancement, thus to control the ground movement. As the TBM advances, tailboard is stabilized by means of grout before installation of the permanent tunnel lining. Grout settlement due to TBM could be attributed to several sources, including the inherent conical shape of the chute, cost of tunnel advancement, etc. But the aforementioned controls are of paramount importance. Exceptionally large settlement or sinkholes, like what we have seen in the slide just moments ago, are generally due to large ground losses at the face of the tunnel, either due to poor planning or inability to maintain the desired phase pressure. High-risk areas are, for instance, the launch of the chute, or breaking out into shaft or excavation, or the encounter of misspaced material, like between the strong and weak soil, or even misspaced of rock and soil, where the groundwater seepage could be notorious. Ground improvement is often carried out in the launch and docking area just to ensure the safety during the event of TBM breaking and docking. Upper right shows the displacement field of the model throughout the stages. From there, we can see it is critical at the early stage of the advancement due to adjacent tunnel effect, which then mellows down over the distance. And here is just a close look of the deformation behavior at the ground level in the heat map, the kind of representation. And this is how the powerful post-processing algorithm restores the three-dimensional reality at high resolution. In most of the cases, tunneling design in terms of geometry, alignment, and support pressure are governed by the serviceability criteria in order to minimize the impact on the existing infrastructures. With modern TBM technology nowadays, it is not difficult to control the volume loss within 3%, even for the poor ground condition. In practice, TBM tunneling induced ground settlement is mostly estimated based on the empirical relationship or guidelines. Those mostly provide site-specific characteristic parameters for prediction of ground settlement in terms of volume loss and trough width. However, empirical methods are unable to consider the supporting effect of the TBM shield in the calculation of volume loss, and consequently, the relatively conservative value of volume loss is adopted in ground settlement control. This in turn leads to conservative estimation of ground settlement, which then might require unnecessary ground improvement or reinforcement as countermeasure. Therefore, for economic design and planning of shield TBM tunneling, reasonable prediction of volume loss based on reliable analysis and monitor ground settlement is essential. The beauty of FEM is that it lets you account for a wide range of behaviors going into the analysis. It greatly overcomes the limitation of traditional analytical method for being isolated or oversimplified. Here in Plexus, we typically come up with a so-called analytical model. It's not necessarily a one-to-one copy of the actual site, but just some features essential from the geotechnical point of view. These are, for instance, the terrain and subsurface profile, especially along the alignment. In fact, the variation of ground condition as a result of investigation would pretty much set the tone for the tunnel alignment. In general, we want to avoid existing underground infrastructures like foundations, basement, and utilities. It becomes increasingly difficult to achieve though, in the already congested urban cities. Sequential excavation method, often known as NATEM, the new Austrian tunneling method, involves a sequence of construction activities in a typical cycle. The method has a lot more flexibility in the sense to accommodate large diameter arbitrary shaped tunnel in rock formation. Drill and blast is often used in conjunction with this method, whereby support for excavation is realized by means of shotcrete, rope bolt, and fall pulling. All these features, so are the series of time-dependent behaviors, can be incorporated in a single model in Platsys, just like that. All right, so with this last frame, I'll conclude my presentation. So now turn it over to the host.
You think? It was very interesting. And before we come to the Q&A session, I already answered some Q&A whilst Thing was speaking and Martin. I would like to have a few polls. One is a compulsory one that I was asked to. Following the presentation of today, would you like to be contacted by a sales representative from Bentley Systems? Yes or no? Of course, we would like to hear yes, but if you say no, you say no. We're not going to be angry. And if instead you want to email me with specific questions or difficulties you might have encountered at some point, you can also just email myself. So I'll leave this up for people to say yes or no, whether you would like to be contacted. And then, just to get a bit of a feel for the audience, we wanted to ask which of these systems is your organization currently using, like 2D CAD, BIM, civil engineering software, means like OpenRail, OpenRoads, or competitor equivalent. Any digital twin technology already? And are you using model-based geotechnological methods as explained by Xing Cheng? That just out of curiosity. And if you want to pick any of these, I think multiple is also possible, I think. Then we can actually show the result. There's still more people voting, so I'll wait a little bit longer. Yeah, and then, okay, so, more people voting. I think, even more people voting. I'll go to the result now. So, it's pretty CAD, BIM, and civil engineering is, quite, I think I would expect something like this. I'm happy to see civil engineering software is the winner here. Digital twin obviously is new, and these Plexus methods or similar also new. Now, I would like to now invite, so Mylene, are you still here? And Xing Cheng? Then we could answer some of the questions that came up. Actually, one that I answered before was the question about, because I only touched lightly on the question of the construction management. And that's because there's a follow-up session, which is next week, similar to this, but really focusing in on construction management and using software synchro to simulate the construction sequencing, and also other things that can be done, like managing RFIs and quantities and so on. So, yeah, can Xinchen and Mylin, are you actually there?
Yep. I'm
Yep.
here.
Yeah.
Yep. Mm-hmm.
Did you have a look at the questions? Did you see? One question is, what weakness do you see in this technology or areas that can be improved upon? I'm not sure what, I'm guessing from the timing that came in, this is probably related to, I don't know, maybe the plexus part.
Yep.
I don't know.
So yeah, so I would like to elaborate a little bit on this limitation currently that we have right now. So OpenRail is a reality modeling software, while Plexus is practically a analytical software. So most of people will go after the interop between the software. So due to the different implementation of the program, so the full interoperability is not quite there just yet. So the reason we don't emphasize on that is because now currently the interop is not there. So if you want to do it, you need to actually do it by part. Like you want to pull some geometry details, like from OpenRail to places like alignment or typical cross-sectional data, you can do so. Yep, so it's currently still doable. Yeah, but it's not, the full interop is just not quite there just yet. So there's the current limitation that I see. Yep, but along the way, we're improving it. Yep.
And you have a workaround, right?
Yeah, workaround is based off, I think it takes a lot of individual engineering judgment. So which part you need from the OpenRail model. I mean, for analytical modeling, the typical ingredient is the cross-section of your tunnel, your alignment. All right, so you need to selectively weigh in the importance of those geometry features and pull from there accordingly. Yeah.
Okay. So another question, where can I find comprehensive training resources on OpenRail? Mylin, can you say something on the training on OpenRail?
Okay. For those who have already an OpenRail license, okay, you get to, of course, together with your license, you get an access to the Learn server. So we have this Learn server from where there are specific learning paths that you can enroll in on demand. And some arrangement could also be done if, let's say, you are going to go through the training through your organization. So we have some packages that you could more or less some customized ones that is based on your requirements. Okay. Now, if you would like to have your own self-learning done, we have a YouTube channel for OpenRail. So just Google or just type in OpenRail designer. Then it's easy to see the YouTube contents. And apart from that, if you saw the resource list, we have a PDF that has links, or that has, you can download the PDF link or PDFs of the ebook of OpenRail. So it will give you like a detailed information as to the overall information about OpenRail, and also some of those necessary or relevant materials related to OpenRail. Okay, so it's basically we're everywhere, and you can also join for free. We have a Bentley Communities website from where you can just join the OpenRail communities as well. Okay, but basically, if you want really the full learning units, you have to really enroll using our Learn server. So Learn, LEARN, that Bentley.com. I will type it in the chat box if you would like to. Okay.
Yeah, thank you, Merlin. Another question that can this be used for pipeline designing, especially cross-country pipeline? I'll try to answer that since I've been involved in this type of project. So pipeline, if you have, for example, a large sewer, right, this is from a design perspective similar to a metro borehole tunnel, right, when you're talking about open rail. But if pipeline, so there's also like the drainage that goes alongside roads, and for that there's another module in open road and open rail as well. But in open roads, mostly that's used where you have the subsurface utility engineering module, which actually we had a different webinar on that, which is for water drainage, a pipeline across country. Yeah, but it can be used. Definitely, we have the technology for these. Do you want to say something on that, Mylin? Additional?
Yeah. Anything subsurface, be it drainage, other utilities underground, you can do that in Open Rail Designer, and the thing is we have different approach for you to do the modeling. So it could be corridor based, meaning if you remember my presentation, there is a cross section, right? So your pipe could be also be laid out as a corridor, or if it's object based, you have some libraries of those typical nodes or inlets, and then you connect it through pipes, which can differ in diameters. So we have quite a lot of approaches or workflow for you in OpenRail.
Yeah. So the last question, maybe because we're already over on 5 minutes, is has this software been tested in African countries? On that, I'm pretty sure it has. Like the office I would refer to for this is our Dubai office. And yeah, I mean, I know in the Middle East, it's all this technology has been used extensively. I know that for a fact. And in which other African countries? I would ask my colleagues in Dubai. So I'm just gonna type my email here, then you can email me and I can forward to our Dubai colleagues who are covering Africa. Yeah. So thank you very much. Yeah. Thank you for attending in good numbers. Interesting questions as well. You can also, we'll go through and see if we missed any question here. Yeah, later we'll go through. And thank you for attending. Any other comments from Xinjiang or Mylin?
No, thanks.
No, thank you, everyone.
Thank you all. And next week, next week we'll have the session on Synchro, and the following week we have something more related to operations and also station design. So you can check my LinkedIn. There, these sessions are advertised there with a link as well. There's a multi-registration link as well. I can send you. Okay, thank you very much and have a good evening or good afternoon.
Thank you.
Can
Bye-bye.
you send us one more? Can you send the record? Actually, you can take the same link you logged in here, like later, maybe not immediately, but 1 hour or like tomorrow. I'm not sure how long it takes. You can then see the same as a recording. I don't know for how long, but you can just go back to that same link and see it again. So for all of those who ask for materials, the easiest thing is to go back to the same to the same link and view it again and again, and as often as you want. And there's some material downloadable on the menu. Yeah, somewhere that you find the materials. Yeah. And if any questions, email myself or my colleagues. Or send me a message on LinkedIn. All right. You see the name in the middle. Thank you. Bye.
Bye-bye.
Bye.
Bye.